The Lego Mindstorms Tic-Tac-Toe Robot by Team013, Jason Fielder, Justin Dees, and Cameron Fellers.
The project at hand. For the tic-tac-toe robot project, our team needed to design a code that would actively play a game of tic-tac-toe with a user or against itself. The code for the project combined 4 different codes, each program telling the robot when to move and where to move in order to win the game. Our final MATLAB code should be able to play a game of tic-tac-toe with the user and never lose.
Strategies. Step 1. If there is a place on the board where the computer can place a move and win, it should execute this move. Step 2 is blocking. If there is a way the opponent can win the next move, block them. Step 3. Create a fork, making it possible to win in 2 different ways or block an opponent's fork. Step 4. Place a move at the center. Step 5. Place a move in the opposite corner that the opponent is in. Step 6. Play an empty corner. Step 7. Play an empty side.
Strategy explained. Our team chose the strategy because it's a simple strategy and straightforward, and if it is followed, the computer should never lose a game.
Here are examples of the strategies we use. After incorporating our strategy into MATLAB, we tested several different possibilities to see whether or not the computer could lose. An example of the computer strategy can be seen below. In the following example, the computer marks with an O and the user with an X. The computer should block the move, and then it creates a fork for itself so that the user has to block one of the 2 moves and then wins the game.
Initializing the robot. Before every game and after every move, the robot's arm must move back into place and the board must rotate to its initial position. These movements were accomplished through sensor and motor commands that tell the robot when to move and where to move in order to complete the game without losing.
Moving the robot. Our team wrote a program that was dependent on a certain space inside the board. Commands were entered into the computer program that directed the robot's arm to a certain distance and caused the board to rotate to a certain angle. These combined commands made it possible for our robot to place a marker in the correct position.
Displaying the board. In order for the robot to correctly scan and display the layout of the board, our team used the color sensor on the robot. After hard-coding the X's and O's values to correspond with blue and yellow markers, the robot was able to pick up on empty spaces and the spaces containing either blue or yellow balls and successfully display the current state of the board.
Putting it all together. All 4 codes were then focused into one final code that allowed the robot to play tic-tac-toe with the user or against the computer. By intertwining the strategy with movement for the robot, the final code was able to work through the robot to win or tie in tic-tac-toe.
In conclusion, our team successfully wrote 4 codes in MATLAB that define a strategy, command the robot to execute the strategy properly, and never lose the game of tic-tac-toe.